Okay, yesterday, or last class, we stopped at angular momentum, which is I equal to I omega. Then we use the principle of angular impulse and momentum, which is H1 plus sum of moment time equal to H2. Okay, remember I, you have two components, Ig plus md square. You use this one when your interest point are away from the center of gravity. Okay, so this one is from table. If no table or the shape is irregular, then you'll be given radius of gyration I equal to mk squared. Okay, we continue with the last part of this chapter, and then next week we'll do revision. After Raya, then will be your test 2. Test 2. Today we learn about conservation. Conservation of momentum means there's no changes of momentum. Momentum have two, one is linear momentum, one is angular. So if this one you learned before, if it linear means move in a straight line, left, right, up, down, in a straight line, then linear momentum means mass multiplied by velocity, mv1 equal to mv2. However, for angular momentum, conservation also same. It's just in the term of angular, mean h1 equal to h2. Okay. What is the purpose of finding or using conservation of momentum? For linear momentum, mv1 equal to mv2, usually you want to find velocity number 2. mv1 equal to mv2. So this one, usually this one is missing. For angular momentum, I omega 1 equal to I omega 2. Usually you want to find what is omega 2 or what is the initial omega. Okay. So we look at example 4. If you have a circular body and it was intended to roll and then go up to A, then drop down. So the height of A is 0.03 meter. The radius of this circular body is 0.2 meter. You're given a mass. So when you are in the rigid body chapter, remember, if you're given a mass, remember to go to the center of mass and draw W. Put in the W. You're given moment of inertia in this case, because we already know how to find the AG from the table. So straight away, you'll be given the IG. But if it's in the assessment or test 2 or final exam, you need to find the moment of inertia. Assuming the wheel does not slip or rebound, determine the minimum velocity of the center of gravity, Vg, just to roll over the obstacles of A. Just to roll over. So you need to calculate the angular momentum. Okay, you use impulse and momentum diagram. Okay. So because of no slipping or rebound, the wheel essentially pivot about the point A during the contact. So this one means is roll and then touch this point, and then you want to find the velocity when it's go up from A. So you draw the impulse and momentum diagram before H1 plus impulse momentum m dt. So it's m dt. So this is before the impact. So it's roll and then before it touch A, the center of gravity move to the right. So you have mv. So for rigid body, especially when it comes to chapter 8, we are more focused on mv, momentum, mv. Yeah? So mv, and then every object that is rolling, you have ig omega 1. Ig omega 1 is your h lah, angular momentum. mv is the linear momentum. Ig omega 1 is angular momentum. Okay. Then the distance G to A will be, you take 0.2 radius minus 0.1. You are interested to find the distance over here. Okay. Plus the impulse given to the wheel during impact. So during impact means the wheel touching the point A. When there's a touching, mean every time there is a 90-degree to the tangent of that particular surface, because it's round surface, so always tangent. So I draw an arrow there. So there's a force pointing at the surface, multiplied by the time you get impulse. And W go down, force multiplied by time, you have the impulse. So this is the linear impulse, linear impulse. And after the event will be the momentum, like this one. Copy this one and put over right hand side, but this after impact. Okay. So the velocity vector after impact, it will shift down. So when it roll, before it touch A is the far left diagram, and middle diagram is when it touch point A. The last one, the one on the right, is the one that it go up. Okay, when it touch A and you go up, so velocity go up this way. And then because it's continue to roll up, so you have Ig omega 2. Okay. So this is just to tell you that force at A in this direction will be bigger than your weight. How you know? You split this one with the angle. You know that the y-axis must bigger than your W. Okay, this is just a introduction. Then you put in, okay lah. So this one is just some introduction or some explanation. So force A is much greater than the weight. Since the time impact is very short, the weight can be considered impulsive. Impulsive force F at A has both unknown magnitude and direction. To eliminate, so we will take that angular momentum at about A is conserved. Okay, so we use conservation. We limit this in the middle one. So your angular momentum, you have two. One is linear, one is angular. The center of gravity here move in a straight line. So you have a straight line momentum, mv, straight line, plus rotation, you have angular momentum, right? mv plus the radius. So this one go this way. So plus the contact A here. So it will rotate clockwise. So this one, this mbg1 multiplied by this distance. Okay, this is r comma is this distance. H2 is this diagram. So H2, this vector mv momentum multiplied by the distance, perpendicular distance, plus Ig omega 2. So here you have the R, you have the M. VG, VG need to look for the, okay, VG, you need to look for the answer, or you can transform your V into W. So V equal to omega R. You can change the V into omega R if you want to eliminate. If you don't have the V, you can change the V into omega term. Okay. So this one you can calculate the omega in a non-slipping scenario. Vg divided by R is your omega. So you have 5 Vg equal to omega. So in this case, the question asks you about Vg, so you cannot change this one into omega, but you can change this one in terms of V. You can change omega into V. So you substitute. Ig is given in the question. Ig is given in the question. This one substitute by this one. So at the end, your Vg will equal to 0.89 Vg1. Okay, so this is using conservation of angular momentum. Conservation of energy, you can still also apply using, but if you use conservation of energy, it do not apply during the impact because energy is lost during the collision, but just after the impact, you can use lah. This one is just read. We won't use this one. This is another approach lah, if you use conservation of energy. Right? So we only compare before it hit point A and after it climb up point A. So two kind of energy you use, kinetic and potential energy. Your datum put at the center before it climb to A. This is a datum line. So before datum, your mgh will be 0. This one will be 0. Okay, this one will be 0. So your kinetic, remember kinetic, you have mv square and I omega square 2. Okay. This is on a rigid body. Rigid body, when you rotate, you have another kinetic energy, half I omega 2. This one 0 because no potential, because it's 4 at the datum mgh h0. And then after it reach point A, no kinetic is stopped there, right? It's stopped there, no kinetic, so 0. Then you have the mgh. This is the height it climb up. This is the height. It roll over, it climb up here. Okay. You substitute, you will get the same results. You get the same result. Okay. Okay. Another one, example 5, is a rod and you shoot a bullet with 30-degree in, hit this point, so this rod will rotate. So chapter 6, 7, 8, you need to consider the initial effect. So when something knocks something, it will going to have initial effect. So in your calculation, you need to use the I multiplied by something. So VB coming in given, the dimension is given 0.75, 0.25. Mass is given. So remember, every time mass is given, so the center of the mass will act at the center of the rod here. pin at O, so there's O point here, initial at rest, so omega 0, V 0, alpha 0. If 4 gram bullet fired into the rod and the velocity given, determine angular velocity of the rod just after the bullet become embedded, means it's go inside there. Embedded means the two mass join together already. So your total, of course, this gram is very, very small compared to the 5 kilogram. It's very, very small. Okay. So this is to estimate the motion after you knock some object and then go together. So you can estimate using diagram, impulse and momentum diagram. H before plus momentum impulse diagram equal to angular momentum after. So you imagine what before and then equal to after. So this is what happened before. Okay, what happened before? You're looking at the rod, not at the bullet. You look at what happened at the rod. So this is before the rod is coming in with a momentum hitting point A at a certain angle. This one is at a 30 degree. Distance O is 0.75. This is the H, the H angular momentum. Then the center one is the impulse. Impulse, you're dealing with forces. Forces multiplied by time, you get impulse. So there's a pin there. Pin means you have OX, OY. Multiplied by the time, you get impulse. There's a W there. W also force. Force multiplied time, you get impulse. And bullet. Bullet go inside there already. Hit there. So weight of bullet will go down, although bullet is only 4 grams, very, very small. Okay, so bullet go inside there. Then after you draw all the point, O point, G center of mass of the rod, and then the bullet also. Okay, so the G center of gravity, although it will swing anti-clockwise, if you look from the far, the center of mass will move to the right. The rod will rotate anti-clockwise in Ig omega 2. And this point, the mass of a bullet will move to the right also. So by using this impulse and momentum diagram, you apply into this H1 plus m dt equal to H2. Okay, so this m is moment. You need to convert force into moment. Force into moment. So in this one, because bullet is very, very small, you can eliminate from the analysis. So this one, after that, you can consider, because it's embedded, you can see as a singular system. The rest you read. This also you read. So you have these things. So what can we eliminate? What can we eliminate? Since the time of impact is very short, the rod move only a slight amount, so that the moment of the weight impulse at point O is essentially 0. So if you put your hand here at point O, do you see any moment generated? No. If you put your hand here, W go down, the D 0. How do you create moment? F and the distance must be perpendicular. Then only you create moment. So this one is at the same axis. W do not generate anything. W bullet also do not generate anything. Okay, so all point cannot move left, right, is or pin there cannot move, so no moment there also. Okay, so no moment, this one 0. So it become center one becomes 0, then is arrived at conservative of angular momentum. Okay, so H1 before equal to H2, then you do your calculation. How to do H1? H1 do not have rotation, so you only have translation. Translation, you are moving in the so this one mv is a vector with an angle. You can change this one to x and y. When you change this one into x and y, you know that y-axis do not generate moment. Y do not generate moment, x only generate moment. So this is the direction of x. How you find x direction? mv cos theta. You get the x direction arrow at here. So here, mv multiplied by 0.7, you get the moment. Okay, so this is a mv momentum multiplied by distance, you get angular momentum. Same is here. We are referring to O. So here you have two momentum here and one ig omega 2. So you have a three things there on the right hand side. Okay, so mv bullet multiplied by the distance, you get angular momentum. This is momentum multiplied by perpendicular distance 0.75. Right, this one multiplied by the distance here. Then the rod mv multiplied by 0.5, because this one at the center of mass at the half of the rod, plus the ig omega 2. So you have all the m, all the v, m1, v1 you have. This one you can calculate. This one you have v vb2. vb2 and vg2 actually is the same because they are embedded in the same body. Okay, so you arrive left hand side, you have vb2, you have vg2 and omega 2. Then you further simplify. Then you use kinematics, syn rod pin at O. Then you can find the omega by using vg2 equal to omega r. You can simplify. vg2 equal to omega 2 r, but they share the same omega 2. Yeah, vg2, vb2 share the same value of omega 2. You substitute back, you find omega 2. Once you find omega 2, substitute back here, find your vg2, find your vb2. Okay, find your omega, substitute back to here. You find your vg2, find your vb2. Right. The question only stopped at this answer. It asks you what is the angular velocity. Okay. But when it comes to test or final exam, you need to find velocity of the center of gravity, center of mass, and the velocity of bullet after it embedded into the object. Okay. Okay. With this, we conclude chapter 8. I will give you one more tutorial question, and then I see you next week. Okay, I'll stop the recording first.